Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, proofs involving congruent triangles, parallel or perpendicular segments, and CPCTC. So using a lot of those more recent topics and kind of putting them all together. So we're going to use the given information to prove that AB is congruent to CD. So these are going to be congruent on the kind of left and right sides of our shape. So given BC down here is parallel to DA. Okay. And CD left is parallel to the right one. Okay, so these are different, so I'm going to use two arrows. Prove that AB is congruent to CD. All right, so let's see what we've got here. I need to start listing these out first. So statement, reason. All right, first, because I have a feeling there's going to be a lot of stuff to keep track in here, I'm going to list my givens out just so I don't forget them, because that's where everything's going to build off of. So just list out those two statements given. And let's see what else I know. Okay. So I know this has to be congruent to itself. It's one of those shared sides. So AC is congruent to AC by the reflexive property. And I'm going to use some of these parallel lines here. So if I look at DA and CB, these ones, then this one and this one are alternate interior angles, because that one's kind of cutting across there as a transversal. So I can say that angle DAC is congruent to angle ACB because they are alternate interior angles. And this is where ALEKS often uses the very long version where they say if two lines are parallel, then alternate interior angles are congruent, which is the very formal way of listing it. So that's what you're looking for there if you are doing this parallel to me. Pun intended. All right, anyway, so moving back here though. I can also say, if I look at these two as my parallel lines, then this and this are also going to be alternate interior angles of our other parallel set there. So angle DCA is congruent to angle CAB by the same reasoning. Okay. And so that's enough actually, because I have two angles and the side in between them for the ASA method. So I can say that our two triangles are congruent now. So let's go ahead and just list them off. So DCA, maybe. Triangle DCA is congruent, and this is where I have to make it match up on the second one. So that would be BAC. And that is going to be by the ASA property. And so that being I have two angles that are congruent and the side in between them is also congruent. So now I know that, so I should be able to get this pretty easily because they are corresponding sides, yeah. So they're the two ones that go from our double to the blank. So double to the blank, they're the same sides. So I can say that they are congruent because they're corresponding. And corresponding parts of congruent triangles are congruent. That's CPCTC. That's all I need, so I'm good to go.